Thank you for having me today, and I'm very glad to be here in KAIST because this is the first time for me visit the KAIST, and I'm very excited to provide some presentations about my work today, to especially for the KAIST student because you guys are so smart, if I correctly know about you guys. But anyhow, so today I'm going to present some of my research focusing on the modeling people's behavioral process with respect to using the on-demand mobility solutions. Before explaining about my research, I'd like to introduce me to you in more details about the research interest. Actually, the Professor Chan already explained very well about me, but I'd like to emphasize that my research interest is about the demand forecasting. Actually, demand forecasting is kind of the core of the transportation planning. Actually, transportation planning is something about decision making for transportation policies or mobility solutions or etc. Actually, to develop very proper or very effective transportation policies, we have to understand people's reactions about those policies very exactly. And based on this behavioral understanding, we can very accurately forecast demand of certain policies. Actually, therefore, I'd like to say that the demand forecasting is the most important thing in the transportation planning. But in the past, but still now, actually, the forecasting demand for railway or highway is very important in our field. So I'm very good at forecasting those demand for the highway railway. But as you know, these days there are kind of the emerging new solutions to solve transportation problems like the ride sharing or car sharing, autonomous vehicle based solutions, etc. So to forecast demand of such new solutions, we have to change the methodologies for more accurate forecasting of the demand. So therefore, my current research interest is trying to represent people's kind of the behavioral process or mode choice process or some kind of the behaviors in using some new solutions in terms of the forecasting demand. Okay, so in this background, I'd like to explain more motivations or background of our today's presentations. First, I'd like to start with this kind of the paradigm shift in our field. Uh, like your department, how can I say, like your graduate school, your graduate name of your graduate school has been changed recently, right? From the transportation to the mobility. Actually, likewise, these days we are using the term of mobility rather than the term of transportation to describe the people's movement or the logistics or whatever, right? So actually, behind this kind of phenomenon, there is kind of the paradigm shift. What I want to say is that when we are talking about mobility, we are tending to focus on the people rather than the facility. But when you were talking about the transportation, we tend to optimize the certain facility of transportations because we have a kind of the fantasy, which is that we can solve transportation problems by optimizing our the facilities or transportation networks or something like that. But more important thing is that we have to understand why people need transport, why they need to move, and what they want, something like this. So if we exactly, how can I say, understand their needs of mobility or needs of the movement or needs of the, yeah, yeah, whatever, then we can provide very proper solutions which may be very convenient for user and which might be very sustainable in our society. So this is kind of the new trend. Then this is one of the my favorite metaphor to describe kind of the new solutions in this transportation area. The current mobility services, like the public transportation, is kind of the ready-made clothes. On the other hand, the something new solutions should be like the custom tailored clothes. So which means that the current public transportation has the fixed schedule with a fixed route or something like that. Therefore, we have to change our schedules to be kind of suitable to the public transportation schedules. But in the future, these mobility services should adjust their schedules to fit to our schedules, like the tailored clothes. Actually, this is not very easy to achieve. Yeah, let me explain more about this using some more technical terms. Actually, the transportation mode can be classified into the two different factors or two different domains. And the first one is accessibility, and the other one is privacy. Privacy can be interpreted as capacity for a single vehicle or something like that. Then, as you already knew about that, the private car has the kind of the highest accessibility in terms of the door-to-door and in terms of the frequency of service because the private car is our own mobility options, so we can use it whenever we want. But the taxi provides almost door-to-door services, and especially these days, we can call a taxi using an app. So, which means that the accessibility is very high in terms of the frequency of services. On the other hand, when you look at the train and bus, as you can imagine, the accessibility is relatively poor. But as we know, the train bus has the much higher capacity than the taxi and private car. So what I want to say is that always there is kind of linear relationships between the accessibility and the capacity, right? Some traditional or conventional solutions is always on the line like this kind of the trade of relationships. But new solutions I'm sorry, must be located this part. So which means that this should be able to break this kind of the classical relationships. In other words, new solutions should provide high accessibility and high capacity at the same time. Actually, this is not really easy, but there are a lot of the solutions, or how can I say, very smart ideas tried to achieve that kind of the areas. I will briefly explain to you some examples. You already knew about this Uber. Uber is kind of the on-demand solutions, right? So which means that this let's say app is trying to optimize about the vehicles in our systems by reducing the empty or the vacancy in the seat in the our vehicles or something like that, right? So they try to match the idle vehicles and the travelers' requests, right? And the second one is the demand responsive transit, especially Korea. How can I say? Tries to expand these DRT solutions to very diverse regions. But anyhow, I think you guys are already familiar with these DRT services. But anyhow, this is also based on the people's request, right? So when people are call a bus and this bus is dispatched like the taxi, but if the another passenger call another ride, then the route can be changed to provide the bus services for the another users or something like this. And third services is kind of the car sharing. Actually, in Korea, there is only not only, but anyhow, the Soka is the most representative car sharing services in Korea. But the SOCA is very limited version of the car sharings. But when you look into the diverse cases in the world, the free floating car sharing services is a more kind of the general, especially in the European countries, which provides kind of the one-way car sharing services uh, within the designated areas, something like that. This is also kind of the on-demand mobility solutions. And yeah, like this micro mobility is also kind of the on-demand solutions. This is kind of the sharing mobility, yeah, sharing economy-based mobility solutions. I'd like to skip these pages because you guys are familiar with that. But what I want to say is that these are on-demand mobility solutions quite close to the new solutions, what I explained to you. So which means that these solutions can provide higher accessibility compared with the traditional public transportations. But at the same time, it can provide higher capacity or higher efficiencies in transportations. But important thing is that from the user's perspective, always we have to do something for using these solutions. For instance, first we have to request a ride to the company, and after that we have to check kind of the quality of the result of the matching, and then we make decisions whether to join these services or not, something like that. Blah blah blah. And when you are looking into the vehicle sharing services, and first we have to search some solutions, and then we make a choice to use a kind of the shared vehicles, something like that. So actually, this kind of processes is kind of the extra processes compared with the traditional public transportations. So one of my research interest is about the what is the potential factors affecting the people's behavior intentions to use such new solutions. The classically, actually, this kind of travel context, like the trip purpose or travel time, travel cost, will be very influential factors affecting people's behavioral intentions in general. And the personal characteristics also very important, but kind of very common characters, yeah, affecting the people's behavior intentions. But I wanted to focus on these factors, which means that actually there is some kind of the request process. We have to wait for the services, especially there are some uncertainty in waiting time and uncertainty in the availability or something like that. So I just wanted to know how these factors affect people's intention to use on-demand mobility services. And actually, this research question is very similar to how we develop a model representing the people's decision-making process, which is influenced by these factors. So today I'm going to explain briefly about my latest researches. Actually, I will skip this slide. Okay, so I'd like to start with very general modeling approaches about the people's behavioral process. Okay, actually, we have to make a lot of choices in our life, including uh, uh, regi yeah, residential locations or mobility options like the buying a car or joining a car sharing services or etc. And when we are looking into the daily life, we always, how can I say, consider which kind of travel mode will be very convenient to reach certain destinations or something like that, and travel routes as well, blah blah blah. But what I want to emphasize that all these choices or all these behaviors is relatively easily observed. So which means that we can directly investigate the people's behaviors in the field just by asking their behaviors or just using some survey questionnaires or something like that. Or there is a lot of big data, right? Which helps us to understand people's behavior, right? How many those data set is very helpful for us to understand to what extent the people use subway, to what extent the people use car, something like that. So this behavior is relatively easily observed, which is we say this is observable. At the same time, some possible factors influencing this behavior is also observable. So, for instance, the people's age or income level or travel cost, travel time, such things is relatively easily observed in the field. But what we don't know is that the people's decision-making process. This is kind of the psychological process, right? So we know their I'm sorry, we know their result, which is the behavior, and we know about the factors which will influence the people's behavior. But what we don't know is that how these factors influence people's decision-making process and how these process make this kind of the consequence. So therefore, the modeling travel behavior or modeling behavior intention means that uh, developing a mathematical model to represent this black box. But I'm sorry about that. This is not a black box, right? This is black, this is white. So I have to change the color next time. Anyhow, this is a black box for us, right? This is white box for us, right? But anyhow, there are diverse methods, but I personally prefer the discrete choice theories to describe the people's decision-making process. I think some of you guys are very familiar with the discrete choice analysis or discrete choice theory. I'm not going to explain the details about the principle of the theory, but this is kind of the econometrical approaches to represent the people's behavior with respect to the mutually people's behaviors to make a choice among the mutually exclusive alternatives. For instance, uh, actually, yeah. Let's just think about this discrete market. Uh, when you are traveling, you cannot use the private car and bus at the same time, right? We can transfer two different modes, but we cannot use these two transportation mode at the same time, right? So, regardless of our budget, regardless of our willingness, we have to must choose one of them, right? Either of them. So therefore, discrete choice theory is something about the the representing people's behaviors to make decisions among the very how can I say uh, kind of uh, yeah discrete goods. And there are diverse theory and diverse models about that, but the login model is one of the popular model for describing the discrete choice theory. If you are familiar with the first step demand forecasting method, and the third step is about the mode choice or modal split. Actually, the logit model or logit formula is very can say very uh, yeah, again, logic formula is used in that step, right? And actually, this is the logic formula. This model assumes that people tend to choose an alternative that maximizes the utility among the alternatives. So, in other words, in this black box, somehow peoples are evaluating the utilities for each alternative. For instance, they are evaluating some utilities about the Uber and evaluating the utility about the bus and evaluating the utility about private car. After then, they make decisions which can maximize our utility, right? So this is kind of a very classical and traditional assumptions about people's behavior in general, not only in the travel behavior, but also in the any kind of behaviors in the economics. Okay. So based on this kind of decision-making process, which is the relatively simple, there are many variations about this model. Uh, okay. Yeah. First, the logic model assumes that people's sensitivity is similar or same to any kind of the situations or something like that. But as we know, our taste is totally different from the other's taste, right? For instance, even for the same public transportation fare, some people feel that, okay, this fare is too expensive. But some people say that, okay, this travel fare is too cheap, something like this. So mixed logic tries to accommodate this kind of the heterogeneity in the people's taste variations in the decision making process. So actually the rule is exactly same with the logic model, but parameter is kind of the random parameter to describe diversity in the our populations. Uh, uh, and the second model is the latent class model. Actually, this is more, how can I say, clearer than the mixed logic model. Actually, mixed logic model using the random parameters, yeah, seems like fancier than latent class. But from the policy implication perspective, actually, the latent mixed logic model does not tell many things for the planners or researchers, but the latent class model has more clear result, which might be more interpretable to the researchers. So this model assumes that the populations can be divided into the different groups of the peoples, and each group has different, can I say, um, 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 uh, let's say this evaluation process about the utilities when they are making a choice. And so this is the rated class model. I will explain this part later. And the third one is a hybrid choice model, which is that actually this utility is kind of the latent variable, right? Because we cannot measure directly the utility. Utility is kind of a very affirmative term in our mind or in our brain or whatever. But there is another psychological factors like the attitude or values or personal, how can I say, preference, something like that. So this model tries to capture the other psychological factors which might affect the people's choices. So this is the, we call this is hybrid choice model. Okay, but still, these three models assumes that people's measures utility for each alternative, and they make a choice which can maximize our utility. But relatively lately, there are another suggestions. Actually, this utility is not always works, or maximize utility maximization assumption is not always works very well. Especially there is an uncertainty or risk in the choice situations. For instance, um, when you were thinking about travel mode choice to going to the airport, actually. So if we miss that airplane, it's something terrible, right? So therefore, we make a decision based on, how can I say, we try to minimize some kind of uncertainties in our travel time to reach our the destination, something like that. Even it's more expensive, even it takes a longer time, but more important thing is that kind of the guarantee to arrive the airport when we want to arrive, right? So likewise, there are some kind of another behavioral theories, which is a prospect theory or regret theory. Actually, these are assumes that people's consider the prospect or the regret rather than the utility when making a decisions, especially there are some kind of uncertainty. I will explain more about the regret model later. But this is kind of the alternative to the traditional logic model. Okay. So this is kind of the brief introduction about the behavioral models based on the discrete choice analysis. And from now on, I will explain briefly about some empirical result from my research. This is the list of the papers. So if you are interested in, please check the um, yeah papers. Anyhow, first research is about the car sharing decisions. Actually, car sharing decisions can be divided into two different stages. The first stage is the midterm mobility decisions. For instance, we have to make a decisions whether or not to join these car sharing services. Actually, these days, there is no registration fee and there is no kind of the fixed cost for being a membership. But like 5 years or 7 years ago, there are a lot of companies who just received some membership fees when they are joining a car sharing or something like that. So therefore, we may have decisions whether or not to join these car sharing services for our future demand. What I want, what I focused is that I focused about the effect of inherent uncertainty in car sharing services. As we know, the car sharing services provide a shared car, which means that many peoples share a single vehicles, actually, conceptually, right? So, which means that there it can happen. No car is available at the accessible the point when we wanted to use. Actually, this is kind of the uncertainty. So, in other words, even if I joined car sharing services, there is kind of the situation. There might be a situation that there is no car we can use. So I just wanted to know. I just wanted to investigate the effect of these things. So I collected the data. I'm not sure you guys are familiar with the stated choice experiment, but I used, how can I say? Um, I collected a lot of data using this stated choice experiment. So yeah, and after this seminar, if you are interested in the stated choice experiment design, so please let me know. Then I can, yeah, share my knowledge with you. But anyhow, because this is kind of the hypothetical situations, we asked the people what kind of the choice will make based on these hypothetical situations. But then, yeah, skip this page. Yeah, it looks very complicated, but I just propose that the existence of uncertainty in the car sharing services, yeah, I try to represent this uncertainty here, like the availability of car use. So, which means that uh, uh, there is some kind of probability to be able to use a shared car is only 90 percentages. In other words, 10 percentage, there is the chance that no car is available. So I just assume that this kind of the uh, non-availability affect people's decision-making process. So I just employed some regret minimization method. Yeah, just skip it. Actually, the regret minimization method assumes that people tend to choose an alternative that is able to minimize our anticipated regret rather than the utility. So this is one of the their hypothesis. Yeah, yeah. This is. I think this graph is better than the previous one. So what I found is that the availability of the shared car has very strong influence on the people's behaviors to join car sharing decisions, and especially the my proposed our proposed model based on the regret theory is performing very well. So therefore, we can interpret, yeah, this kind of the result. Okay. Uh, yeah, because of the time limit, I just skipped the. I just explained each slide very quickly. So if you have any questions, and then please let me know after my presentations. Okay. And the second research is about the also the car sharing decisions, but this is for the short-term mobility decisions. After joining a car sharing organizations or a car sharing company, then we are able to use a shared car as a transportation mode. So in these situations, we have to think about which transportation mode is more kind of the beneficial for our travel, right? In this time, I considered about the effect of activity travel context, especially if there are some kind of where is it, time pressures. Okay, if we have to, if there are some time pressures for making a decisions, I assume that people might use the different rules to making a decisions. So that is my assumptions. So this is kind of the proposed model using the latent class models. So I just suggested a model for representing intrapersonal heterogeneity in decision-making process, which means that even a single person, their decision rule can vary according to the activity travel context. So, which means that if there are some um, time pressures, and people tend to follow the random regret minimizing process. On the other hand, if there is no time pressures, or if we have enough time to evaluate each alternative, then people might follow the random utility maximizing, which is the based on the assumption of the rational behavior. But anyhow, as the result, yeah, results suggest that this minus value indicates that when there are some time pressures, then people, the probability, how can I say, the probability to follow the random regret minimization process will be higher or something like that. So, which is that this is a consistent with what I just explained to you. But because of my research, therefore, always the result and motivation is consistent, right? Otherwise, we cannot publish those papers in the journal. But anyhow, so this is one of the examples for the how to use this kind of latent class model or the different rules for representing people's behavioral process. This is the last example. Uh, yeah, actually, as we know that Seoul metropolitan area has very large mode shares for the public transportations. Uh, this 23.5 indicate the bus and the 13.5 indicate the subway. So total 37 percentage of trip are made by public transportation. I think that is very high proportions. But when you look into the commute mode, which is normally used during the morning peak hours and the afternoon peak hours, still the passenger car, which is the private car, has takes the largest proportions among the total trips. So what I want to investigate is that I just want you to investigate whether these new solutions, on-demand solutions, uh, 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 can be a kind of the attractive transportation mode for the commuters. Otherwise, their impact is very limited in our society. So, but when you think about these characters, there are very opposite characters between the commuting behaviors and the on-demand solutions. Actually, the commuting requires kind of the regular patterns every morning and every similar time. Okay, yeah, and repeat every day, so something like that. On the other hand, on-demand solution requires kind of the request, waiting, matching, something like that, right? And especially there are some uncertainties. So I assume that on-demand solutions is not really, really attractive in the commuting travels. But what I expect is that actually this flexibility in the working time might be compensate this kind of the negative impact of our on-demand services. Actually, during the COVID-19 situations, I think we were experiencing a kind of the flexible working time and flexible working areas, locations, right? So I just want you to know that whether this kind of the flexibility in our working schedule has positive impact on the on-demand solutions or yeah, something like this. So yeah, I also collected data from the stated choice experiment. So I just wanted to measure some working flexibility index. This is kind of the very psychological term, right? Even the one guy can have very flexible schedules. Like for instance, you can choose the 9 a.m. or 10 a.m. for your commuting time, but different people can evaluate this flexibility differently. Certain person has think about that this variation is very flexible, but on the other hand, other person yeah cannot feel this kind of variation is flexible, right? So therefore this is kind of very subjective evaluations. So I'm trying to measure those subjective evaluations using the Likert scale, and then I already explained to you. I'd like to quantify these psychological factors using the hybrid choice models, and I try to simultaneously estimate the relationship between this latent variable in the travel mode, something like that. But the result does not show very, how can I say, very attractive. But I will explain the details about it. But what I would say that generally speaking, uh, this minus negative sign indicates that people do not prefer these solutions as the commuting mode compared with the private car if the other attributes are same. So basically, especially this one-way car sharing, DRT, car sharing, lounge car sharing is relatively poor compared with the private car, right? But when you look at this, yeah, something like that. Okay. So, but for instance, if the working time is autonomy, which is that we can choose the working time ourselves, then DRT, utility of DRT can be increased, or something like this. And if working time is very irregular, then DRT has the lower utility, something like that. On the other hand, this one-way car sharing trip has the higher utility compared with the others, something like that. So what I'm saying is that actually the travel mode choice is highly associated with our working styles. So I want to know what kind of working style is kind of suitable to these on-demand mobility solutions. So that is the one of my research questions about the third papers. Okay. From now on, I will just briefly explain to you about my future direction of the researches. Uh, okay, so far I just explained to you very, how can I say, very cross-sectional behaviors, and very how can I say, very average behaviors about people's decision-making process. But as I already explained to you, we have very sequential decision-making process to use our mobility solutions. For instance, first we make a decide the travel mode. In other words, first we have to make a decision whether to call a taxi or not, right? And after then, uh, there are some the matching result that we make a decision whether accept this matching result or not, right? And after then, we have to wait something. But sometimes, if the waiting time is the longer than what we expected or longer than the informations, sometimes we refuse the course or something like that, right? So actually, this kind of the decision-making process is kind of very sequentially connected to each others. So one of my PhD students tried to develop a model to represent this kind of the sequential behaviors using on-demand mobility solutions, especially using uh, kind of the reinforcement running process, something like that, but still ongoing study. But there is one PhD student. Actually, this guy is the my first PhD student. Yeah, my first PhD actually, and he just graduated. And he proposed a kind of the travel mode choice model for trip chains. Uh, uh, yeah, I will not explain details about that, but as we can imagine, our travel mode choice is highly dependent on our previous transportation mode. In other words, if we use a private car at the first trip, then our second trip and the last trip to home might be made by the private car because we start to using the private car. On the other hand, if we are not using the private car at the first trip, then we have to choose the different transportation mode, right? So therefore, we thought that this kind of the transportation mode choice is connected with each others, right? And especially we are thinking about the one day schedules, right? If we have a kind of the business meeting in another city, then we just decide to bring our car when they leave our home, something like that. So what I want to say is that we proposed a kind of the backward and the forward searching process during the schedules. So actually, I think you guys are familiar with this kind of the RNN or recurrent neural network. So we just tried to adapt this neural network models. Especially there is a bidirectional neural network models which provide the forward and backward. How can I say? They just sending the informations from the next stage, and then they use this the previous stages informations or something like that. But anyhow, so we just re-represent these structures to represent people's scheduling behaviors as one day. So this is one of the output of this PhD student. And then the last week, actually, this paper is accepted in the TLB. So if you are interested in, then if you have a plan to go there, then you can just yeah see the more details about that. But anyhow, to summarize, and actually the modeling people's behavior process is a little bit the psychological things, but at the same time, we have to be able to represent these very tricky kind of the behavior to forecast more accurate demand, right? So there are two different approaches. The first one is that just assume the using the discrete choice analysis, and the other one is that there are kind of the emerging methodologies like the neural networks or whatever. But anyhow, such things will be might be helpful for representing the people's behavior. Personally, I tried to the both ways. I tried to develop this classical method, which is this choice analysis, and the other way is that I try to adapt this neural network things to represent people's decision-making process. But as you know, such method, the late method, needs a lot of data. Actually, they are highly depends on the quality of data and the size of data, something like that. So we need to data-rich studies for better understanding. In addition, actually, the transportation demand forecasting is not very simple because there are a lot of factors, and we have to understand a lot of the stages in our daily life. So therefore, we need to very comprehensive models to account for all different domains, all different things. And the last one is that actually so far I just explained to you very independent model. So in other words, every decision maker is an independent from the other decision makers, but our behavior is influenced by the others, right? So we are influenced by our friends, we are influenced by our family members, or sometimes we are influenced by social media, right? So these are also very good research topics for yeah, modeling the travel behavior or behavioral process. Okay, this is the end of today's lecture. So thank you for listening about the lecture. Then if you have any questions, please let me know. Okay. Any questions? Yeah. 양보라고 그래.
Uh, Thank you for providing us very interesting your presentation. Um, can we see slide 37?
This one?
Yeah. Yes, yes. I want to know why on-demand solution indicated poor result compared to private car. I mean, why uh, why they are not attractive compared to private car?
Okay. Yes, actually, based on this model, yeah, we cannot perfectly interpret why this kind of the result captured. But what I assume is that actually this model is based on this kind of the experiment. Oh, sorry. Yes, this kind of experiment. We just shows them diverse options, and we just ask the respondent to choose one of these options or something like this. And actually, the travel time for the private car is based on their real time. So we first ask their real time, and based on these values, we uh, uh, yeah, add some variations randomly for the other options, something like this. But what I want to suggest is that, yes, so, and when you look at this, uh, the population is the owner of a private car and who uses a private car to commute within the past years. So what I would say is that basically they prefer the private car and basically they own a private car. So that is, I think, one of the reason. Okay. But as I said here, so I just wanted to know whether this kind of new solutions can uh, be an alternative to the private car. So that is one of the research questions. So I think that is one of the main reasons.
Uh, and in this slide, there are four attributes and six scenarios. I
Uh,
mean,
yeah,
you conducted
six
y-
alternatives, right? Yes,
yeah, six alternative and four attribute, four characteristic, right?
yes,
Ah, okay.
yes,
And waiting time is included in um access time or egress?
yes. Access time. Yeah, actually, that is very good questions because when you're looking into the using the public transportations or car sharing, whatever, actually the waiting time is very important, right?
Yes, yes.
But so the previous version of the experiment actually there was an then the waiting time, but what we realize is that actually the from the respondent perspective, it is very tricky to differentiate the access time and waiting time. For instance, we can call a taxi at the office, right?
Yes.
So then if we have very uh, clear informations about the arrival time to our office of the taxi,
Yeah.
then we don't need to. It is kind of the waiting, but this is not real waiting time because we can do some other things for this waiting time, something like that. So and so therefore access time is also highly related with the waiting time, something like this. So we just decide to integrate these two times into the access time here.
Okay, thank you.
Hi. Thank you for the presentation. My research is actually about forecasting demand based on the activity-based model. So I'm very interested in this kind of works.
Thank you.
So I believe the quality of the data is very important in this task. So if you want to evaluate your models and everything, you should be able to like capture the valuable data from the diverse people, right?
Yes.
So um, what I do is mostly data driven. So I do generative AI stuff to make those kind of attributes,
Hmm.
whether people would choose next like choices for the
Hmm.
modes and everything,
Hmm.
durations and everything. So
Hmm.
I should be able to generate the activity schedules.
Hmm.
So since the quality of the data is very important, so
Yes.
right, I need to actually analyze the impact of the autonomous vehicles.
Hmm.
So I should consider the acceptance of the AV cars
Hmm.
in my modeling process.
Hmm.
So achieving that data is impossible. So it's like, would you still consider doing the surveys to collect those kind of
Hmm.
data,
Hmm.
or do you suggest the other ways to do this?
Yeah, I think that is very good point. Actually, the stated choice experiment has very long history, like the 100 years ago. In the marketing field, they want to know this new product, how many people willing to buy about this new product or something like this. Actually, this classical approach is very looks very old, but I think this is still very powerful because we don't want to know all people's behavior, but if we want to know very specific parameters for certain behavior, then I think still this kind of stated choice experiment is works. It's just you mentioned that to modeling the activity travel behaviors, we need to have a lot of data, right? But yeah, we can say that the best data set is kind of the household travel diary data in for now, which is the real data. Otherwise, we have to generate data based on something, right? But still, only the model based on generated data. Yeah, let me rephrase about this actually. So, if we have only small informations, but that is truth, then I think it will be very helpful for improving our model. So, what I want to say is that uh, I'd like to suggest you to both. Yeah, the first you need to generate data to have very rich data set for your modeling, but still you need to validate about your models, and we have to check some specific part of your big model. And for that, still this kind of classical approach is very working very well. And lately, many researchers tried to improving these stated choice experimental technologies, not only from the mathematical perspectives, but also the practical perspectives. For instance, wearing VR is kind of the improving the reality in the experiment or something like this. So if you can combine those things, it will be very helpful. Or some driving simulator, that is also kind of the stated experiment, something like this.
Okay, so if I understand correctly, still the survey data would be powerful to capture
Yes.
this kind of
Yes.
things, right? I have another question. So, we incorporate the social demographics like ages and genders and everything. So when you conducted this study, what kind of features were powerful? I mean, what kind of features were mostly affected for the peoples who are driving? I mean, deriving this like utilities.
Okay, so you
Yeah.
mean that among the social demographic characteristics, right?
Oh, or any other data you used.
Actually, it depends on the like this choice situations.
Mm.
So I don't remember all the my previous researches, especially about the factors. But what I want to say is that basically the age is kind of a good kind of indicators to differentiate those utilities, especially for the on-demand mobility services. And in addition, some psychological factors is very highly influenced. For instance, uh, there are some people who has very strong privacy seeking. Then such people do not use any kind of the sharing solutions or something like that. And there are some person who like driving itself. And then those people does not care about the autonomous things, something like this. So sometimes understanding those psychological factors is very helpful for forecasting demand.
Thank you.
No one will have questions for you. Um, 36, I think,
Hmm?
slide 36.
It's 36.
Yeah, the previous slide, or
Yes.
maybe not. Um, that one.
Yeah.
So from probably my interpretation is wrong. So from this table, um, you don't really know how much new services can take the trend demand from the private car.
No.
Okay. Yeah, it's okay. So interpretation is right. And it seems like your research um, direction, not direction, but the methodology used to be statistical analysis.
Yes.
Now you tend to switch or change to
I
more
think
like a deep learning,
data-driven.
yeah, data-driven
Yes.
approach. Okay. My question is why do you do that? Do you have any particular reason
Yes.
for you to encourage students to
Yes. Yes.
those research area?
I think that is a very good point. Personally, I don't like AI. I don't like neural net. I don't like machine learning because what it says that actually I admit that these approaches is very fancy and actually these approaches provide us very insightful result based on the rich data set. I agree with that. But actually, from the demand forecasting perspective, uh, the findings based on the historical data has some limitations. So, because rather than that, understanding the why people do that is much more important than just data. So, which means that we have to forecast the future situations rather than the historical situations. So, therefore, personally, I prefer this kind of the theory based approaches rather than the data driven approaches. But these days, I also realized that this kind of the theoretical based approach has very high specification errors, so which means that everything is very simplified. and every factors are linear in parameter relationships. Everything should be independently each other's, something like that. But this kind of the data-driven approaches or neural network things has the very powerful, how can I say, representations about some non-linear relationships in very complicated situations. Actually, our behavior is very complicated, right? There is no single factors can explain our behaviors, right? So what I just realized is that um, this kind of the complex model which can represent which can how can I say accommodate very non-linear relationships in the behavior. In that sense, I think it might be very helpful. What I just explained to you about my PhD student research, which is the this one actually. First, we tried to expand the discrete choice models for describing the people's trip chain-based mode choices or something like that. But we just realized that this is not good enough for representing complex behaviors, but just by adapting these bidirectional recurrent neural networks, then it relatively easily representing the people's complex behavior. So that is one of the motivations about that. So these days, I'm trying to make more interpretable and more represent, which can represent the people's true behavior, the complex behavior, or more better, or using this kind of the neural networks. But still, I just, how can I say, have two tracks for our research.
You also think it's more publishable in the future for your student?
That is very good reason.
Okay.
Yeah, yeah, as you know. Yeah, that is one of the very reason, right? Yeah, that's true. Yes, because yeah, if we are not using machine learning, then the paper is not published very well.
Any further questions from student? Yes. Can you pass this to?
Thank you for your presentation. I have some specific question regarding the experimental design. So first, about the stated preference survey, we usually have the description of the scenario, right?
Yes.
Do we have to specify the OD pairs sometimes, or we try to make the scenario more abstract
Yeah,
for the respondent?
yeah, that is very good point. Actually, I developed many different the state choice experiment. But what I want to say is that how can I say, the making it real is not always our goal. What I want to say is that we cannot represent perfectly the real world in this state preference experiment. So we have to make decisions. What kind of aspect we want to focus. So sometimes, as I said to you, when I want to looking into the effect of a travel context, then I just add this kind of the scenarios like activity durations or time pressures. On the other hand, the other state choice experiment, I did not include any travel context informations, which is very abstract. But I wanted to focus on the comparison among the attribute. So what I want to emphasize is that based on my personal experience, we cannot perfectly represent the real world. So therefore, we have to choose some specific part based on our research
Question.
goals. Yes.
Thank you for explanation. Because sometimes if you specify the trip purpose as the commuting trip, right? And then the respondent will have some fixed choice.
Mhm.
Like if you say that it's a commuting trip, then I always take the public bus from home to the working place.
Mhm.
Then the choice is like binary, right?
Yes.
But you provided like maybe 6 alternatives.
Yes. Yes.
Then
Yes.
you do you mean that I need to collect the most frequently used alternative first?
Mhm.
Like this one. For
Mhm.
example, is this one. Of course, you specify that the target population is the
Mhm.
public private car users. But if we only consider the transit user or like general users, then when I make the choices, I only compare the choice between like maybe public transit with the DRT,
Yes.
right?
Yes.
So how can we solve this kind of problem?
Yeah. Mathematically speaking, I think that is kind of the choice set generation process. If I correctly understand about your comment. Yes, right. So actually, there are kind of the model combine this choice set generation and the choice because there are diverse alternatives in kind of the real market, but everybody consider how can I say uh, not always consider every alternatives when making a choice. Like as you just mentioned that among the 10 alternatives, we just only consider 3 alternatives in the real time, right? So I think that is very good research kind of the yeah, research questions, right? So for instance, you can show the 10 different options, and the first you can ask them uh, among them how many choice options will you consider for that? Then they can first choice 3, for instance, and then after that you can make them choice one of the 3, something like this. So that can be the possible solutions.
And one more question.
Yeah. Thank you.
For the theories,
Huh?
we usually have 3, right? Utility, prospect, and random regret.
Yes.
So how can we choose to specify our model using those theory? We just try it, like both of them, or among all of the 3 theory, and then based on the model fit, then we say maybe utility maximization is the provides the best model fit.
Yeah.
Can just based on our research question and just pick one. We don't have to justify it.
Actually, I did both. The first one is just I just picked regret theory because I just insist that this is very suitable, then I just use it.
Yes.
But luckily, anyhow, it was accepted. But anyhow, the next one, I did the same things, but the reviewer said that, okay,
Yes.
yes, I just mentioned that. How can you prove
Yes.
this method is the
I
best?
met this
Yeah,
kind of
something like that.
question.
Yeah. So therefore, what I did is that actually this is the this one. Uh-huh. So when you look into my paper, then I just compare with the different scenarios, like the utility maximization and utility maximization 2 classes, and the random regret single classes, random regret 2 classes, or this combined classes or something like that. And then I just compare with the model fit, or there are diverse goodness of fit indexes, and then I just prove that this one is the better, but very slightly better, but anyhow, or something like this. So yeah, I think that is also very good point. I think that is not easy to, how can I say, just justify the which kind of theory is better than the other, something like this, right? So yeah, so if you wanted to apply those things, then I'd like to suggest don't insist one of the method is the superior. Just compare 2 different things and then just interpret why this difference can happen or something like that. I think would be more acceptable. That is what I thought.
Thank you very much.